Hi everyone, this is Pre-Algebra Lesson 8-3. Make comparative inferences about populations. In this lesson, we'll be able to draw comparative inferences about two populations using median and interquartile range. So the IQR comes from the box plot, so we'll use a lot of box plot in this lesson. So get ready for that. Let's start with explore it. LS serves as a random sample of 20 7th graders about the number of siblings they have. So the table shows here results of her survey. We have students A, B, C, D, ... until T, and the number of siblings are shown. So part A, draw a model to show how Ella can best display her data. So you can represent data in multiple different ways, right? One is a dot plot, another one could be a box plot. So what are we trying to do? She is surveying these students about the number of siblings they have, and another way to represent data would be the box plot. So let's figure out how to draw a box plot. In order to do that, what do? What's the first step? You list the numbers in the order of least to greatest. So there are 2 zeros, 0, 0. Wait, how many do we have? 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So 20 students. It was also mentioned in the question. I just wanted to double check. 2 zeros, and then 1, 2, 3, 4, 5, 6, 7, 8 ones. 1, 2, 3, 4, 5, 6, 7, 8 ones. And then 1, 2, 3, 4, 5, and 6 twos. 1, 2, 3, 4, 5, and 6 twos. And 1, 2, 3 threes. 1, 2, 3 threes. And a 6. And make sure you have everyone, all the data, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10, we're good. And then we're gonna figure out the median. So the median, you count from the minimum and the maximum outside to inside. So 0, 3, 1, and 3 here, 1 and 3, 1 and 2, 1 and 2, 1 and 2, this one and this 2, this one and this 2, this one and this 2. So those two are our middle numbers. What if we have two numbers as median? You find the average between those two numbers, and that could be your median. So your median is going to be 1.5, which is exactly in the middle between 1 and 2, okay? And then you want to figure out your Q1 and Q3, quartile 1 and quartile 3. So your median is where it splits. So then you start counting from your lower half. So 0 and 1, 0 and 1, this one and this one, this one and this one, this one and this one. So these two are the median of the lower half. So your Q1 is 1. So your upper half, 2 and 6, 2 and 3, 2 and 3, this 2, this 3, this 2, this 3, wait, this 2, this 2. So these two are your median for the upper half, and the average of those two is 2. So then you have your Q1, median, and Q3. Your minimum is 0, your maximum is 6. So draw the box plot on your number line. You need to have a number line, so 0 through 6. And then your median must be 1.5 here. And then that's your median. And then your Q1 is 1. Q3 is 2. So you make a box that goes through all these points. And then your minimum is here, maximum is here, draw whiskers. All right, that's your box plot. Explain why you chose that model. Why did we choose a box plot? because the box plot is a good visual representation to see at a glance the numbers of siblings where it's concentrated between 1 and 2. So like we want to see where they're concentrated, where most of the data are. So if you look at dot plots, there may be different clusters. It might be a good visual representation to just make an overview of it. But if you want an accurate data, like a more accurate representation of where the majority of your data are, your half of data would be in this box, okay? So it's really good to see the number of siblings that are concentrated between the box, so between 1 and 2. And the range should be from 0 to 6. And so 6 minus 0 is 6. Okay, so focus on math practices. Using your data display, what can you infer about the number of siblings that most 7th graders have? So using the data, what can you say? We can say that half of the students will have siblings ranging between 1 and 2. So usually most 7th graders have either 1 or 2 siblings. And then it's spread out throughout 0 and 6. But the data is clustered. Data in the model is clustered at 1 and 2. So that's our sample answer. Most 7th graders have either 1 or 2 siblings. The data in our model are clustered at 1 and 2. Okay, the next page. Our lesson essential question is, how can data displays be used to compare populations? Let's start with example 1. Use box plots to compare populations. Finn and Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? So these are the hours that 20 students spend on homework each week. And so in Finn's school, it's going to range between 1 and 11, and you see a lot of 4s and 5s. Jonah's school, we see the same range from 1 through 11, but you can notice that the numbers are bigger than Finn's school. So let's look at step 1. Display the 2 data sets in box plots. So if you look at the 2 box plots, you can see where the majority of your data is by looking at the box. So Finn's data set, if you look at this box is between 3.5 and 6.5, and the median is 5. For Jonas, the box is between 5.5 and 8, and the median is 7. So what are the relationships that you see? The median best describes the data because both data sets have outliers. Step 2, you're going to use the box plots to compare the 2 data sets. What can you say? The line for the median of Jonah's data set is to the right of the line for the median of Finn's data set, which basically means the median for Jonah's data set is higher than Finn's. So Finn can say that the median of Jonah's data set is greater. The box for Finn's data set is longer. The box is longer in Finn's. So Finn can say that his data is more spread out, it's more varied, and has greater variability. So it has it varies more. Okay, so those are the things you can infer from the box plots. Let's look at try it. Kono gathers the heights of a random sample of 6th graders and 7th graders and displays the data in box plots. What can he say about the 2 data sets? So compare and contrast the box plots in this try question. See if you can fill in the blanks by yourself and see if you can answer the convince me problem in your own words. Come back when you're ready for answers. Okay, are you ready? So let's start checking your answers. The median of the blank grade sample is greater than the median of the blank grade sample. So that's the top one. The top box is 6th grade, bottom box is 7th. So you see 6th grade as median here, 7th grade's median is here. So whichever is on the right would be greater. So you can say the 7th grade. And then the median, then the 6th grade sample. And the blank grade sample has greater variability. So which box is longer? The 7th grade, so it will vary more. So how can you visually compare data from the two samples that are displayed in box plots? You can compare them, compare the medians, and you can see how the boxes are spread out, and compare the boxes from each other, and you'll be able to compare and contrast. So this is the sample answer. You can compare the medians and where the boxes are relative to each other, as well as their lengths, which is IQR and range. So the box length would be the IQR. The range from minimum to maximum would be the range. You can talk about all of those when you're comparing data with the box plot. Let's look at the next question. Example 2. Draw inferences using median and interquartile range. Finn and Jonah analyzed the measures of center and variability of the data they collected. Do these measures support Finn's assessment of the two data sets in example 1? Let's see. So if you look at the Finn's data set, so half of the values are in this box. 25% of the values, so the lower half would be here, and the 25% of the values, the upper half of the half would be here, right? So if you look at all the important points, first quartile for Finn's data set, 3.5. Median is 5. Third quartile is 6.5. Interquartile range is 3. Because Q3 minus Q1 is 3. In Jonah's data set, 5.5 is Q1. Median is 7. Q3 is 8. And IQR is 2.5. So the median of Jonah's set is higher than median of Finn's. And so the students at Jonah's school generally, that means this is what it means. You can't just say, oh, it's higher. So what? That means the students at Jonah's school generally spend more hours on homework each week than the students in Finn's school. Does that match your example 1 here? Yeah, Jonah's data set here also has a higher median than Finn's data set. So you can say that it goes along with each other. So the IQR of Finn's data set is greater, which means the data in Finn's data set would be more varied. So there is a greater variability or spread in the number of hours students in Finn's school spend on homework, and it goes along with example 1. Okay, example 3, draw more inferences using measures of center and variability. So how can we draw more inferences? Mr. Bonson had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks. How do the 2 populations compare? What inferences can be drawn? So if you look at these box plots, you can see that the median heights are the same. But are the boxes the same? Are the minimum and maximum the same? No. Room 7D has a lower Q1 and a lower Q3. 50% of the plants in 7D are between 8 and 14. The IQR is 6. 50% of the plants in 7G are between 10 and 16. The IQR is 6. So there are things that are similar. There are things that are different. So while the median heights of the plants are the same, the plants in room 7G are generally taller. You can infer that the growing conditions in room 7G are more favorable for plant growth than in room 7D. So although the medians are the same, IQRs are the same, it may be there may be some differences if you look at your position of the box. So it does depend on your position of the box. So let's look at try it. A local recreation center offers a drop-in exercise class in the morning and in the evening. The attendance data for each class over the first month is shown in the box plots at the right, morning and evening. What can you infer about the class attendance? So looking at this box plots, please make an inference and please make as many inferences you can make from this data. See if you can figure it by yourself. Come back when you're ready for answers. Okay, are you ready? So more people would prefer which one? To drop into the evening class than to the morning class. Maybe there are reasons for that. Maybe that are obvious because a lot of people prefer not to get up early in the morning maybe. Maybe it's just easier to drop off in the evening because you have work or you have school, you have other things to do in the daytime. So yeah, that's what you can infer about it. So more people prefer to drop in to the evening class than to the morning class would be enough. Let's summarize our lesson. So in this lesson, we learned that we can use data displays using the box plots to make informal comparative inferences about two populations. So we learned how to compare the two box plots. So you have to talk about the median, the IQRs, the boxes, the spread, and the variability, and minimum and maximum, and where most of your data are. So there are a lot of things that you can infer from the two data set here. Okay, even though the medians are the same, your boxes might be different, and your range would be different. So you can take a note on that. All right, that was lesson 3. We'll continue with making more comparative inferences about population in our next lesson. See you in lesson 4. Bye.